Here's Unit 9, Day 7. These are the notes to classify quadrilaterals. We're looking at some of the definitions. A parallelogram is a quadrilateral that has two pairs of parallel sides. So the way that you can show that you in fact have parallel sides is to talk about congruent or same slopes. Rectangle is a quadrilateral with four right angles. To show that you have right angles, we have to have perpendicular sides. To get perpendicular sides, we need opposite reciprocal slopes. A rhombus is a quadrilateral that has four congruent sides. How can we show that sides are congruent? To have the distance formula here we have a square, and it's a quadrilateral, and it has four congruent sides, which is a rhombus, and it has four right angles, which is a rectangle. So to show that something's a square, you need to show that it has opposite reciprocal slopes, and it also, with the distance formula, to show the sides are the same. A trapezoid is a quadrilateral with exactly or only one pair of parallel sides. So that's going to be done with slope again. So what this whole lesson is about, not so much about how to use the distance formula, but making the decision on why or what you're going to use to help support your argument of what shape it is. What does the slope do for you? What does the distance formula do for you? And that's really what this lesson will be about. So we'll plot our points. Watch the scale here. -4, 2, -2, 8, (2, 4, 6, 8, 10), 2, 4, 6, 8, -2. So here we have our shape, our quadrilateral, because it has four sides. So most commonly what we'll look at first is slope. Slope's relatively easy to calculate. y2 minus y1 over x2 minus x1. So to look at JK, we're going to say 8 minus 2 and -2 minus a -4. You look at the J and the K. So you take y2 minus y1, x2 minus x1. That's 8 minus 2 and -2, and minus a negative makes it turn into a +4. So that's 6 over 2, which is 3. Next we'll look at LM, the slope of LM. -2 minus 4, 8 minus 10. For LM, you do your y2 minus y1, x2 minus x1. -6 over -2. Two negatives turn into a positive, which gets here to be the same slope. Since they're the same slope, we know that JK is parallel to LM. Four minus 8, 10 minus a negative 2, negative 4 over 12 turns into negative 1/3. Then our last slope, using the J and the M, negative 2 minus 2, and 8 minus our negative 4. So again, these are the same. Since they're the same, we know that KL is going to be parallel to JM. Since we have two sets of parallel sides, we know that we have a parallelogram. Two sets of parallel sides makes a parallelogram. And then if you look closely, these slopes are 3, these slopes are negative, that's opposites, 1/3, so that's opposite reciprocal. Opposite reciprocal slopes are going to make the sides perpendicular. So that means that we're going to have 4 right angles, which makes a rectangle. Now, we know this has 4 right angles, so it's a type of rectangle. We just don't know if the sides are the same length. If you look at the picture, it looks like it. If you look at the scale, though, the x's, it takes 2 steps to match one of the y's. Or I guess you'd say that the other way around. It takes 2 y's to match one of the x, because you go by 2's on the x's. So the scale is making the picture look a little bit different. The picture doesn't look like it has 4 right angles, but that's the scale making it look different. So let's look at the distance. So we'll look at JK. So we got negative 4 minus a negative 2 and 2 minus 8. Negative 4 plus 2 which is negative 2 squared comes out to be 4 plus 36, which is the square root of 40. So that by itself doesn't mean a lot. Now we have to decide what other side that we're going to test. We could test them all, but we already know, since it's a parallelogram, that opposite sides are congruent. So there's really no need to test LM. What we need to do is test the side consecutive or adjacent to it to see if they're the same, because then all of them will be the same. Or is it different? So you have 2 sets of different lengths, which will force it to be a rectangle. So next we'll look at KL. KL is negative 2 minus 10 and 8 minus 4. To do the distance formula, you do x2 minus x1, y2 minus y1. Negative 12 squared, 4 squared, that's 144 plus 16, that comes out to 160. So those are clearly different. So the consecutive sides, even though they look like it here, it's the scale that makes it look different. So JKLM is a parallelogram with 4 right angles therefore a rectangle. On the opposite side, I plotted the points for a quadrilateral WXYZ. Our scale is just 1 to 1. So we have this shape. It looks like these two sides clearly are not the same slope, but maybe these two are. So I can predict maybe what this shape might be, but we're going to test to see if it comes out that way. So as before, we're going to start out with slope. We're going to look for the XY slope. So 4 minus 1 and -1 minus a -2. That comes out to be 3 over 1, which is just 3. WZ gives us 1 minus a -3 and 5 minus 6. Comes out to be -4. Those are not, obviously, they're not the same slope. YZ that gives us 1 minus 4 and 5 minus a -1. -3 over 6, which is -1/2. And then XW. One minus a -3 and -2 minus 6 turns into 4 over -8, which is -1/2. These are the same. So we have one set of sides that are parallel. YZ is parallel to XW. So if you have one set of parallel sides, that shows a trapezoid. So now, a trapezoid clearly can't be a parallelogram, can't be a kite, but it could be an isosceles trapezoid. So what we actually have to rule out is that the leg lengths are not the same. So I'm going to look at the length of XY. So we take our X2 minus our X1 and Y2 minus the Y1. Gives us 1 squared plus 3 squared, comes out to be 1 plus 9, which is the square root of 10. That by itself doesn't mean a lot. I got to compare it to the other side. So now I'm going to look at ZW, which is the other leg of the trapezoid, which is 5 minus 6 and 1 minus a -3. So we square -1 to get 1 plus 16 equals square root of 17. Those are different lengths. So the legs are not the same length. These two here are not the same length. So this is not an isosceles trapezoid. Leg lengths are not the same. So not an isosceles trapezoid. For this shape, for us to get it to mostly fit onto our grid, we're going to have to change the scale here. Call that -2 and 2, so the x values will change by 2's, but the y values can change by 1's. So 0, 6, that was the B. 2, 4, 6, 8 was the A. 2, -2 was the C. And 2, 4, 6. The D just falls off the edge, but we'll make do with that. So we have our quadrilateral. We'll look for slopes. This time we'll try to do the slope as a rise over run. You can count rise over run. Sometimes it's tricky if the scale is different, so you really have to pay attention. Every time we go right to left, we got to count by 2's, and every time we go up and down, we got to count by 1's. So AB. So up 2 and over 2, 4, 6, 8. That's 1/4. DC. Up 2 over 8. That's 1/4. That's the same. So AB is parallel to DC. So next we're going to look at these two sides. So AD, 1, 2, 3, 4, 5, 6, 7, 8, -8, +1. Well, it actually counts by 2, so +2 gives you a -4 slope. And BC, 1, 2, 3, 4, 5, 6, 7, 8, and 2 to the side also gives you that slope. So they're the same. So we know that AD is parallel to BC. So this alone shows us that we have a parallelogram. Two sets of parallel sides. That gives us a parallelogram. Now if you look closely at the slopes, this one is 1/4. This one could be written as 4/1, and the signs are different. So these are opposite reciprocals. Opposite reciprocals show 4 right angles. And if you have 4 right angles, then you have a rectangle. So now, there are different types of rectangles. There's a rectangle that has opposite sides that are, of course, congruent, but consecutive sides that are different. And then we have the type of rectangle that has all the sides the same, so it's a rhombus, and we typically call that a square. So this could be a square. So now we got to test for distance. So let's look at AB. -8 minus 0, and 4 minus 6, negative 8 squared and negative 2 squared. 64 plus 4, that gives us the square root of 68. So by itself, that doesn't mean a lot. Now the picture looks like this is considerably different. But remember, the scale is different. So let's look at the length of AD. So we take our x2 minus our x1, square those, our y2 minus our y1. That gives us negative 8 plus 6, 4 plus 4, gives us negative 2 squared and 8 squared. 4 plus 64, look at that, square root of 68. Now because it's a parallelogram, two sets of parallel sides, we know opposite sides are already congruent. And consecutive sides are congruent. So we have 4 congruent sides. We have 4 right angles. Therefore, ABCD is a square. On the back side, apply to the points for quadrilateral ABCD. We're using a scale of 1. So when you have a scale of 1, the picture looks much more realistic. So now we're going to look at what's happening here. We often like to start out with slope. So we're going to look at the slope of AB. We go down 5 and over 9. The slope of BC, down 5 and over 9. That's down 5 and backwards 9. So that gives us a little bit different slope. They're opposites, but they're not reciprocals. So that's not a 90-degree angle. They're opposites, though, but not reciprocals. So they're not perpendicular. CD, rise over run, that's positive 5, negative 9. So here we have a pair of parallel sides. And then DA, from D to A, we go up 5 over 9. So we have two sets of parallel sides. So we know that AB is parallel to CD, and we know that BC is parallel to AD. Two sets of parallel sides. So we know it's a parallelogram. We don't have any perpendicular pieces, so we don't have any right angles, because we're not at opposite reciprocals. We're opposite, but not reciprocal. So next, what we have to figure out what's going on. This is a parallelogram, but we have to figure out about the side lengths. We know it's not a rectangle, because we don't have the 90-degree angles, but what do we have with the sides? So we got to look at two of the consecutive sides. Let's look at AB. AB 7 minus 2 and negative 2 minus 7. That gives us 5 squared and negative 9 squared. So that gives us 81 and 25, which is the square root of 106. So that's AB. Doesn't mean a lot. We have to figure out what a consecutive one is. We can look at AD, we can look at BC. We know they're the same length because it's a parallelogram. Opposite sides are congruent. They're parallel, and another property is they're also congruent. So let's look at AD. So we take negative 11 minus a negative 2, those are the x's, 2 minus 7. Here we get negative 11 plus 2, which gives us negative 9, and negative 5, which, notice, 81 plus 25, which is the square root of 106. So now, this would mean that all the sides are congruent to each other. 4 congruent sides. So that's going to be a rhombus. We do not have perpendicular sides, but we do have congruent sides.